Now we'll start the next module, that is Unix processes. This Unix processes uh, is all about the Unix system programming that we are going to discuss now. See, till now we have discussed the shell programming. Totally, we are discussing about the shell, what is the shell application, how the shell will interact with the kernel. In that angle, we used to discuss what are the commands, all those things. Now, we are going to talk with the kernel, the process, the function, how the OS is designed, all those things that we are going to discuss. Then that is called as the system programming, Unix system programming. Shell programming is different, system programming is different. But in your syllabus, they have kept some part of the shell program. It is not a complete syllabus. Some part of the shell that was kept in the module 1 and module 2. Another 3 modules is related to the system programming. Now we will discuss about the programs. System program means the C programs. What is the main function, how the processes are created, what is the arguments, environment variables, what are the signals, how the inter-process communication happens, everything that we are going to discuss in this the upcoming classes. As you all know, since you already studied this C program, you have seen the main functions. In the beginning classes itself, I have mentioned that the most of the operating system, they have been designed using the C programming language. That way, the Unix, the Linux operating system, major part it is been programmed in the C. That is why you see the same main function what you have learned in the C here. As you already know, the main function, what is the structure? This is the starting point, int main, then int one integer variable is an argument, another one character array. What is this argument C? The argument C is the number of arguments, command line arguments that you are going to pass. Whenever you compile, after that you execute, whenever you execute, with that you pass some of the values, right? That is called as a command line arguments. That count will be stored in the first integer, the values that will be stored in the second argument. It's an array of pointer. With the index, you can fetch the each values. With the index, you can fetch the each values. This main function, it is not new to you since you have already seen this in the C program. It is same. Where exactly this main function will be? Since an operating system, a software which is being designed using the C language means there should be a starting point. That starting point will be the main function. Who will call the main functions? That is the question. Where is the starting point of the operating system? So for that, what there will be is there will be a startup routine. Startup routine is some set of instructions. A startup routine, it is a small program. That startup routine is going to call the main function. Directly, the main function is not called. Who will call the startup routine? The kernel. Yes, the kernel will call the startup routine, and startup routine is going to call the main function of the system. And this startup routine itself will pass the command line arguments to the main function. Then only the execution of the other program will start. Directly, the main things is not called. Remember, the startup routine will takes the values from the kernel. The kernel will pass the values to the startup routine. The startup routine is going to call the main function. What the startup routine will give to the main functions? That is this one, the number of arguments, the number of that was values that will be passed. Then whatever the content which is there in the main function, that is going to execute. This is about the brief introduction about the main function. Main function will be called by the startup routine. Startup route will be initiated by the kernel. The next thing is the in when does the program will end the main function? At the end, there will be some exit statement, return statement, or when all the instructions are completed, it is going to terminate. Here, every program that you execute, whenever it is in the execution, a program under execution, that is called as a process. A program, any program which is under execution is called as process. When does the process terminates? What are all the possible ways the process can terminate? The possible ways is whenever all the instructions are completed, written from the main. In the main function, all the instructions are completed. At the last line, there is return 0. Some return statement you have included, then it is a normal termination. There can be two types of termination, normal termination and abnormal termination. The normal termination is returning from the main. No, it is not always we return from the main. There are some cases in the program itself, user entered some wrong values or any other something happens. You want to exit from that time. In that case, we use the function exit function. There are two types of function. One is exit, another one is underscore exit function. They have been called in between the program. Whenever you call those function, in that case also the program will terminate. The process will terminate. It is based on some condition. It is our logic. If the user enters, if we have asked for the user was asked to select the PDF files, but the user enters some doc file. In that case, you want to terminate the program. In that case, in the logic, you are going to write this exit function. Or else one more underscore exit. There is a difference. I'll say what is the difference between these two. Or abnormal termination. Calling abort or some signals initiated. What happens is some memory crash happens or some out of the memory happens. In that case, abnormally the program will terminate due to the memory overflow. Something happens that is called as an abnormal termination. That is also possible. In that case, also the process can terminate. There are some threads. When the threads completes its execution, in that case also there can be termination. I think you already know about this process and the thread. A lightweight process is called as a thread. In the thread also, if there are some return statements, in that case also it terminates. It is called as the normal termination. These are the ways of terminating the process. As I said, there are two different processes. One is exit and another one is underscore exit function. This underscore exit, if you use, even though if you want to store some values, some intermediate values, it is not possible. Kernel will, whenever it sees the underscore exit, immediately the control will go to the kernel. The process will terminate. But if you use the exit function instead of underscore exit, if you use the exit function, what happens is the memory, the garbage values, freeing up the memory, everything will be done in the background, and then the kernel, the control will return to the kernel. The control will return to the kernel. That is the another use of this exit function. If you use underscore exit, no cleanup process. Cleanup process is nothing but keeping up all freeing up the memory or garbage collection, all those things that will be not done. Suddenly the control will go back to the kernel, or else exit functions, if you use, some cleanup process will be done and then the control will go back to the kernel. Finally, what happens is there will be a process termination. But before process termination, whether cleanup process is required or not, based on that you have to decide whether to use exit function or underscore exit. These two functions are inside the standard library.h. Within that header file, they have written the logic of these two functions, exit and underscore exit. The See, you have seen in the bracket underscore exit and exit with the status. You have to pass the status, the numbers like 0, 1. These numbers, I think you have seen the exit of 0. Exit in the bracket 0, I think that you have used. That is equivalent to the last line you what we write in the main function, return of 0. Finally, the control will come back to the uh, kernel itself. That status also you have to pass. This integer argument, this status is nothing but what is the condition. There is another function which is called as at exit. There is another function called at exit. See, this is called as an exit handlers. What is this? When this is been used is, see, let us take an example. You want to execute some of the functions. You want to execute, assume that there are some 30 functions, user defined functions you have written. 30 user defined function you have written. One can be addition, another can be multiplication, division, subtraction, modulus. In that way, you have written some 30 functions that you have already stored. If the user selects, he wants only addition, multiplication, and some modulus operation. Only these three functions are required. In that case, what we should do is already the logic of all those user-defined functions has been written. Those functions, it has to register with another function. Which are the functions has been registered? Only those functions will be called by the main function. After that, that will be executed, but in the reverse order. I'll explain once again. See, with the ANSYS, the process can register up to 32 functions that are being called by the exit. There should be the exit handlers. They are being registered by calling the at exit. See, whenever you exit, you want to do some actions. Whenever you exit, you want to do some actions. Those actions you write in the on some functions. They are called as exit handlers. But which are the functions you are going to call? You first register it. How to register? You register with the function called at exit. How to register? You have to pass the function name to that. If you pass the address of the function, then that will be executed. But in which order you have registered, in the reverse order, it will be executed. How many times you register, those many times will be executed. Another thing, remember that. I'll show this example. See here, some header file, two functions we have registered, my exit1, my exit2 void. Within the main function, see here, at exit, my underscore exit2, this is the call, means this is what I register. If it is going to return the value, if it is not equal to 0 means something has happened, it cannot register. If it is, if the return value, if it is not, the return value is integer. You have seen here, int at exit. Int at exit means it returns some number. If it is equal to 0, then this is not going to execute. One minute. See, what happens is in between, whenever you call the function, see if the body of those two functions has been written my underscore exit1, my underscore exit2. The body of these two functions has been written. What is there inside that? There are just only two printf statements. First exit handler, second exit handler. What is the meaning of this exit handler is, in between, if you call the exit function, instead of continuing the execution, some other actions you want to write, those actions you write inside these functions, like freeing up the memory or deleting the memory or allocating the memory or register some files or any share some resources, anything, some actions, close all the file handlers, any actions that you want to do, that you write inside these exit functions. Yeah, that is why the name exit handler. See now, these are the three times. One is my exit2 is registered two times. Exit1 function is registered two times. Exit2 once, exit1 two times. See, whenever we execute this function, the output will be main is done. The first output will be main is done. Then first handler, first exit handler, first exit handler, then the output will be second exit handler. Four printf statements will be the output. First one will be main is done. Second printf will be this function, my first exit handler. Once again the same function, my first exit handler. The last output will be my second exit handler. In the reverse order it is going to print. This is what register. If it doesn't register, then it will print the error statement like this, can't register this function. You have to register using the function called @exit. The next line, the next, do you have any doubts in this? If you have any doubts, you can raise your hand. If you have any doubts, please, you can raise your hand. I'll unmute and you can ask. No doubts. Okay. You can ask the doubts afterwards also. Okay, the command line arguments that you have already seen, how to get the value? See, argument C is number of values. Argument V is the values, actually the value will be stored in the second one. In order to print that, for loop we have written int I equals 0, I less than argument C, I plus plus. In the printf, argument V, percentage D, this is the high. This I will return. So this is how the output will be. Where exactly the test book is. See, this is how the output will be. Argument, if I execute dot slash the file name, and these are the three arguments, three values I am going to pass. The argument 1, argument 2 test, and foo. In the argument first location, the first value will be argument V. If you want this, argument V1, argument V2, argument V3. I think this you all know. In order to run the compile the C program, cc file name dot C, and in order to run the program dot slash a dot out, dot slash a dot out. This is how you compile and run in the Linux editor. In the C, in the Windows, I think in the Turbo C you already know, there will be a Control F9, Alt F9, or in the some other alternate editors if when you use, there will be a separate shortcuts. But in the Linux, it is dot slash a dot out if you don't pass the command line argument. If you want to pass the command line arguments, dot slash the file name and the command line arguments with that. This argument 0 will be the file name. Argument v of 1 will be the first argument, second argument, third argument. That is how the command line arguments you can print. You can get the values in the C program. You have heard about the environment variables. See, in the Unix Windows, if you click on the this PC environment variables, in that environment variables, see here there are so many user variables, there are so many system variables. These are all, they are called as the environment variables. What is this environment variable is, whenever you install the software, a variable is created and the address of the installed location that will be stored here. This is called as an environment variables. Environment variable is whenever the software gets installed, that address gets stored with a one variable that is called as an environment variable. What is the syntax of that? It is a value, name and the value. The name will always be in the uppercase, the value will be always be the address. This is called as a every software, the most of the software, it will automatically it is going to store. You no need to store in this location. Where exactly you can see in your system also you can check. Right click on the my computer, this PC properties, here advanced system properties. In that environment variables, if you go, you can check all the user variables and system variables. User variable means only for this admin. System variable means so many accounts are there in my system. USN1, USN2, USN3. If I created so many accounts, for all the accounts, the system variables are accessible. But user variables is accessible for only particular that account. Here in my system, I am only the administrator. The user variables for administrator, the system variables, both are applicable for. In this way, here the environment list, even that list, the list of environment variables that you can pass with the main function. That flexibility is also there. Like this, I'll show it in that text itself. This is how you can see. In with the main function, till now you have seen only this much. You have written this int main, argument C, argument V. Even you can pass the environment list in the main function. This is also possible. What is the syntax of that? First, that list should be created like this. The environment list consists of home, some address, path, some address, shell, another address, user. See, always the environment of the name will be in the uppercase. The next string will be the address. And these values, it will end always with a null string. Yes, this will always end with a null string. Those values we store it in the environment list. The address of this environment list that you are going to pass as the third argument in the main function. Third argument in the main function. All these things, why we have to pass? If that is the question, then if these values, if they are required in the C program, if in the main functions, if they are required, just by with this environment list, with this list, you can directly access environment V of 0, environment V, ENVP of 1, ENVP of 2. If you directly give, then you will get these values. Then however you want, you can use it. If the environment variables, if they are required in the program, take it as a third argument and you directly pass it. this pointer to the pointer, that will be stored. That will be passed as a third argument in the main function. What this environment list? It is a list of environment variable. What is the syntax of environment variable? Name equals value. Name will be always in the uppercase. Value will be the some address. It will be always end with the null string. Why this is required environment list? It is based on the program. If the logic, if it requires the address of the home directory, directly you cannot use it. If you pass it from the main function, directly you can use it. I think everyone has sent the attendance. The next part, the memory layout, that we'll discuss in the next class because already it is 11:05. Thank you. If you have sent the attendance, you can exit. Yes, what is the doubt? 19 CS 407. You can send your doubt. 19 CS 407. I think you have some doubt. You have raised the hand. You can unmute yourself and you can ask. Others, if you have any doubts, you can send it in the chat or else in the group you can ask. If you have sent the attendance, please you can exit. Sabanayak, I think you have a doubt. No doubts? Okay then. I'll end the meeting now. I think I assume that everyone has sent the attendance.